there's beginner geometry people, there's always just a funny thing that almost everybody does. It may not be funny to you, but it's funny to me. There's different things that students do that I've just grown to think are just funny to me, and I don't let it frustrate me. It's just sort of funny, but I don't understand it. So a 7th grade example of this would be 7th graders, their first time they've had me, I give them the quizzes to fix and tell them to change the answers and fix the new answers, get it back to me the same way you guys do. There's always like multiple 7th graders that over and over, I'll give them a paper back where their wrong answer is 10, and they'll give me the paper, and guess what their new answer is?
10.
10. I will give them back the paper and say, no, 10 was wrong before, you need an answer other than 10, try that again and get me a new answer. They'll, the next day, give me the paper, and then guess what the answer is?
10.
10. And we might do this like 3 or 4 times, and I've learned just over time to just like smile and think, okay, I don't even know, but we'll just be patient and just keep asking them, and they'll figure it out, and they do. Proofs, this happens as well. So proofs, there's a thing that I know that you know, that not just you, but year after year after year, I encounter this same dilemma. So when you're asked to do a proof, and you say this probably right on the quizzes, what's the thing that should appear when you start to do a proof?
The picture.
The picture. Okay, so the first thing I'm going to do is a picture. So here's my sample proof. I'm ripping off one from the book. MAC ADB. What else am I going to do? What should we do? What should you do if we're doing a proof? We copy a picture.
Given.
There's always a given. Okay, on the thing that I'm stealing here from the book, my given is that AD equals CB. So I'll mark that on my picture. AD lives right there. CB lives right there. Those are the same length as each other. What's another thing we should have to start the proof? What we need to prove. Can anybody, they'll usually tell you this, but just to see, if AD is the same length as BC, can anybody tell me what would have to happen as a result of that? What other truth would emerge? AC would be the same as DB. Why would that happen? Like this matched this, so why would this have to match this? Even without geometry reasons, just like life looking at it, if these are the same length, why would those slightly smaller things be the same length? What are you taking away from both? CD just has to disappear. So this is a certain length, and this is its twin. If we just clip off the CV part from both, those slightly smaller segments would still have to match. That's the truth that we could explain why it is. Now it's harder to do than what we just did, the why, but we're going to try to explain why with geometry terms. And then what should we do? What's next in our proof-making life? Make the table, make the column. First column is for statement. Second column is for reason. Reason number 1 is given. Statement number 1. AB equals CB. We just copy this thing, which is an H word. This is called hypothesis. So now let's take a time out from that and connect this back to my rant from a minute ago. So how this connects to your life in comparison to the story I just told. Page 103, I'm not going to grade right wrong. I don't think I ever have. I don't know that I ever would. Page 103, you were asked to do a proof in number 6 of the complement theorem, and you were asked to do a proof in number 7 of theorem 4.4. So if you were going to correctly do a proof of the complement theorem, just like I did, you should start with a picture. And then you should have a given. And then you should have a proof. I'm holding a collection of papers here in my hands from page 103. Would you care to guess how many of these papers for that proof had a picture and a given and a proof?
2.
Lower.
0.
Lower. And then if you look to number 7, which is a proof, care to guess how many number 7s had a picture?
0.
And a given and a proof. We are correct on 0 again. So I know we know that, we know to say that, we sort of know to do that, but when you were presented your first opportunity to do it, you didn't do it. And that's okay, I'm not coming down hard on you, I'm just telling you a story that every time I do this class, the same exact thing happens. That the first day I collect the 103, I go, nope, no picture, no given, no proof. Maybe I need to hit that harder next year, and I try to hit pretty hard. Draw a picture, draw a given, draw a proof, make a column. You know, and the first opportunity to do it, I always get shut out. I don't know why that is. I just sort of smile and give the papers back. So on this 103, in a minute, I'll just smile and give your papers back. For number 6, have a picture, have a given, have a proof. For page 103, the picture shouldn't be hard to draw again, because for the proof of the complement theorem on 103, number 6, here is the picture. On the proof of the complement theorem, they didn't write you the given and the proof, but how did I suggest earlier you come up with the given and the proof and pretty much everything about the complement theorem?
Watch the video.
We could watch the video, or maybe you have it on the notes from what other thing? How can we do the complement theorem? By using the one we already did from the supplement theorem. Just supplement has to do with 180 versus complement is 90. Just make those couple switches. If you have the notes from me, switch mine. If you want to watch the video, use mine. If you don't want to watch the video or have the notes, use the one that's in the book. That's just as good as mine. Whatever you wanted to do, but just mimic that off of that. Then the theorem 4.4 proof, what's theorem 4.4 say? Right angles are congruent. So you want to draw a picture of right angles, 2 of them. You know, A and B or whatever you want to name them. The given involves the things that you get to name are what did you say you were going to draw?
Right on.
So you're given right angles, and you're trying to prove that they end up being congruent. You can all do that. You can all draw the columns, you can all copy that first thing in there. Then whether you can do the full proof or not on that one, I don't know. Okay, and I'm okay with that. Okay, but we at least have to get picture, given, proof. So I just gave these a quick glance just to see if we had success on that, and the answer was no. So I'll give these back, and we'll worry about that another time. Anything else, question about 103 while we're there, briefly talking about that? So then let's look to this. For this one, we had a little discussion there about these big segments were a match, and we're trying to like clip stuff off. Does anybody have a theory on what reason is sort of like implied in that if we've got a big thing and we're trying to shrink it? Subtract. Do we have anything with subtract in its title? SPE, subtraction property of equality. So if we take the one big one, AD, who do we want to subtract off of AD?
CD.
CD. Who is the other big one?
CB.
And who did we want to subtract?
CD.
CD. We had equal things. If we subtract the same thing from both, that's a step in the right direction. That doesn't have to be 2. That could be 3, 4, 5. Sometimes the steps are unrelated, but that's all true. Let's see what else we could think of here. Does the fact that there's triangles really make any difference in this picture? Not really. I mean, that's just sort of a distraction thing. So part of this will be gaining some experience to learn to just focus your attention on pieces of things. So let's focus on just this piece of it. If we just focused on that piece, what am I thinking there? Could you?
C is in between AD.
C is between A and D, and we can use the definition of between. Well, let's try to tie in what we were doing before. What are you used to doing for definition of between? Like if I asked you to do definition of between with this super highlighted picture, what would be your lean? AC plus CD equals AD is the normal way we do that. However, we don't want to do this as an adding problem. We'd rather get ourselves a subtraction problem. So let's look at the picture and think AD minus CD. If 1 plus 2 makes 3, what does AD minus CD leave us?
AC.
AC is correct. The big minus the little would make the other little. While we're at that, let's look at CB minus CD. If we look at CB minus CD,
BD.
BD. Look at what we just wrote. Does anybody notice something that's kind of, I don't know, to my experienced eye, it's striking. To your inexperienced eyes, maybe, maybe not, I don't know. Do you notice anything that just went on here?
Minus CD is like 3 in a row.
Yeah, that's, even beyond that, there's an even stronger match. But yeah, minus CD is around here a lot.
They're all subtract.
All subtract is true. There's a certain property that's about to pop out for a reason that my eye just popped. Transitive's about to pop. Why does transitive pop?
Because CD is using both problems.
It's not just CD though. We need full sides to match. What's a full side of an equal sign that matched to something else somewhere? Okay, CB minus CD reappeared. Who else reappeared?
AD minus CD.
AD minus CD reappeared. So that's my middleman club. I talk about middleman all the time. So if we use the middleman to connect, who is actually connected from one end to the other without the middleman? Who's left? AC equals BD. And what were we trying to prove?
AC equals BD.
Correct, we're done. That is transitive, and we're out. Probably still seems weird, okay, but it'll come with time. Here's a note you could take for yourself, and maybe on your proof words paper or something that you can find later. Some words tend to go together a lot. Definition of between, I have said before, but I never made you write it before, and I'm only semi-making you write it now, but it would be helpful for you to jot down somewhere. Definition of between tends to come along with either A or SPE, as well as transitive. That just tends to be a triple team of reasons that tend to work together. So if you figured out that this was using SPE, or you figured out that it was a definition of between picture, you can kind of anticipate all the other things, because those often come as a package. Definition of between, I don't think you'll ever see without either APE or SPE, and then transitive for sure. Can you stick for one more thought and then I'll say yes. Another thing that does that is the angle addition postulate. The angle addition postulate is always pretty much going to bring with it either APE or SPE, and transitive for sure. That's another like triple team package of things. These come together. AAP comes with the same partners as well. You'd use APE anytime you're trying to make things get bigger than what you're given. You'd use SPE like we just did when we're trying to create something smaller than what we were given. You'd use between if we've got this kind of picture. You'd use AAP if we've got like that friendly kind of picture. So if you file that in your memory, that can help speed you up, because then you don't maybe need all three ideas. You might only need one of the ideas, and then you're like, hey, wait a minute, that's got to bring these friends along. You know, hey, this feels like subtraction. Well, which thing's it going to bring, between or AAP? If that helps, it helps. If not, we'll try and just chip away every time with this. Are you ready to do proofs yet on your own? No. It's just no, not yet. Okay. Hopefully it's a little better than it was a week ago. So I would think it is. A week ago, I don't think any of this would have made any sense. But at least maybe it makes a tiny bit of sense, or you've at least got a couple bit of notes that you can look at and try to like scheme off of those. Let's go 106. 106, I am looking to grab, I am looking to check right, wrong, but first I am looking to just help you. If this can be better by the end of the day than it is now, then get it to me when it's better, by all means. But did anybody have anything on 106 that you're like, I don't know what I'm doing here? Yeah.
8.
8? That's a good one. Okay, so 8, there is a sample one that I did one day, but I'll do another sample one. So what we have is there's an X going on. So what's going on anytime there's an X? Vertical angles in some way. But then they threw on like another piece even beyond that. So there's still vertical angles, and then there's like a bonus section. So we're going to use vertical angle stuff. What can we use if we're just looking at the part that we can see now that I covered the other part?
Linear pair.
Linear pair, and if it's a linear pair, then it's supplementary. We can do stuff with that. Okay, so if I go through here and I feel like doing numbers, and I say 40 and like, I don't know, 60. If I said 40 and 60, I'll go letters, A, B, C. Can anybody tell me what anything else would be?
C would be 80.
C would be 80, because this full side has to add to make 180, so there's an 80. Okay.
B would be 40.
B would be 40, because vertical angles have to match. What would A be?
140?
140, because this side has to add up to 180. Or if I took this out, what's that a picture of again? Vertical angles. And this total was 140. That's got to be the matching 140 for its friend. If there were numbers, that's how we would tackle them. Does that make sense?
Yeah.
Anybody, if it has numbers, your question. Okay. Unfortunately, it didn't have letters, but the process is the same. Like, how did we make this 140? How did 140 get created probably from the 40? Subtracted. So let's say that was an X. What would this be? 180 minus X. What would this be? X. If this were like a Y, how would we figure out what was here? 180 minus X and Y. Does that make sense?
A little bit.
I can try it again.
I get the concept, but it's
Then it's just a matter of doing it.
yeah.
So if I go like this and go A, B,
A plus B would be at the top.
this would be an A plus a B, yeah, because we've got, you know, the vertical angles there. A and B together match that, that's true.
And would both of the others just be 180 minus, and then in parentheses, A plus B.
Is that making more sense?
Yeah.
And try it and see. Anybody else, something about things tonight? I will say this, that question makes the test, for sure, guaranteed. I remember that one. So, didn't tell you what every question is, but that's a question that's worth trying to figure out. Something.
Could we do number 2?
Number 2. So 2, what do opposite rays make? If I have anybody, if I draw opposite rays, what am I drawing you? A line. So when it asks you how many opposite ray pairs do you have, they're also asking you how many lines do you have? Is that okay?
Yeah.
Then they ask you about vertical angle pairs. So A, B, C, D, E, F. Can somebody name me one vertical angle pair out of my new and improved picture? Who with who? A with D. How many pairs of that size are there? 3. Are you with that? There's A is a vertical angle with B, with D. There's 3 pairs about that size.
Oh, okay.
Does that make sense?
Yeah.
Are there any other angles that are vertical angles that aren't really that sized? Yeah, if I put A and B together, A and B together is a match for
E and D.
E and D together. So if I threw letters on here like X, Y, Z, W, B, U, what would be the name of this angle? If I call this S.
VSW.
So USW would be a match for, who would USW match?
XSC.
XSZ. Would there be other angles like that that are made up of the 2 babies? Other than like A and B made a bigger angle?
Yeah.
Yeah, who else could make a bigger angle?
XSV.
Agree, and it would have a friend. You're trying to name all the pairs you can name.
I didn't know if we were combining the.
Yeah, you can, it can be angles of any size, either the littler ones or the bigger ones. So there's 3 littler pairs, but then there's some bigger pairs too. Is that good enough? Anybody, I can rewind, if you don't understand the person, the person asks and then they say they're good. If you didn't get it, I'll try some more for you. You can leech off other people's questions by all means. Anybody 106, anything else I can do to try to make the 106 more comprehensible? Yeah.
Number 6.
Number 6. Okay, 6 makes the test, I guarantee as well. 6 is kind of an important question, both for the homework and for the test. Why would 6 be a fairly important question as a homework aid or as a test point? Yeah, there's like 8 questions to it. So they're saying the link from this to this is that they're complementary. So when we try to link from this to this, what's complementary mean? 90 total. So they're telling us angle 1 is 126. So I'll go here, anybody pick a number other than 126?
150.
150. So who is 150's friend?
30.
30. Who's this one?
150.
Who's this one?
30.
And we'll call it timeout. Does anybody not understand how we can create those out of the 150? Then what was the length from here to here?
90.
Yeah, because they were complementary. So what's this new number we've not seen yet?
60.
60. Who's 60's friend?
120.
Who's 120's friend?
60.
Who's this one?
120.
1, 2, 3, 4. We just got ourselves 7 points on the test someday if you understood what to do with that picture. Anybody want me to rewind what that was about?
How'd you get to 60 on the right side?
It told us in the paragraph that these 2 were complementary, which means 90 total. So if that's 30, 90 minus 30 is 60, and once we've got the 60, you can go around the world. Is that good? Anybody else, something about that? That was a really good question by somebody, because you just gained the class maybe 7 points. Anybody have something else on this 106 that's worth any sort of a discussion? Okay, 109, something worth a discussion. The hypothesis is the thing that goes with the if, do you include if in the hypothesis itself?
No.
No. And then the conclusions with then. One of these sentences they did backward. Instead of if blah then blah, they did blah if blah. So just be on the lookout for that on this. Two, you're trying to rework it so that the sentence is if then. It isn't right now, but you try to rework it to be if blah 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 then blah blah blah. And then we spilled into 110. 110 used a lot of like old stuff. Does anybody need any help with the 109, 110? Relative to most geometry homeworks, that's an easier one. I just want to make sure it was easier for you and not just in my expectation of you. Anybody need any real world help on that?
I don't remember about number 5. I didn't see that.
Number 5, perpendicular rays are on the quiz. Like I'll say to you, what makes rays perpendicular?
The properties of
Oh, I'm sorry, 5. Equivalence relation, there's a quiz question, it's 3 properties. And they'll say, what makes up an equivalence relation? Did that ring the bell already? It's a 6-point quiz question we've done a lot of times. What's one of them?
reflective.
Yeah, that. Reflex with an X. Yeah. It's that club of 3 with reflex in it. Anybody else 109, 110 need a tip in the right direction without me giving it all the way away? I can at least steer you in the right direction. Anything 109, 110, 106, 103, anything about it? Yeah.
Can you do number 8 on 106?
106, 8. Yep, it's going to be a lot like the one I erased, but I can do it again. So what we have is vertical angles, and then there's like another piece coming out somewhere. And then we have something like an A and a B. And we're going to just try to like figure stuff out. So, can anybody spot me, is there another match for B perfectly or not? Maybe there is, maybe there isn't. Does B have a perfect match, Frank?
Is it the one above?
Nope.
It doesn't.
It does not. For B to have a perfect match, friend, since B is like set up by these lines, we would need not just this line to continue, but that one. Okay, so B doesn't have a friend. If this kept going, B would have a friend there, but I didn't play that game, so there is no match for B. Does A have a perfect match for it? Yes. Where is that?
Under A.
Under it, right next to the B. Because this kept going, you know, the A is made up from these, and they both kept going, so it made another A. You okay with that? Okay. So then the question is, maybe do we want to do piece number 1 or piece number 2? I think piece number 1 is easier. Can anybody tell me an answer for piece number 1?
180 minus
Minus who?
B in piece 1.
I disagree with that. But it
180
is
minus
involved
A.
180. It is 180 minus the A. So here's where I focus my attention. Tune all of this out. These two form a linear pair. You usually draw a linear pair like this, probably. I just turned it a little bit sideways in our mind. Okay, so this is just like that. Good with that? If it's a linear pair, it's supplementary, meaning it makes 180. So if this is 40, 180 minus 4 is that answer. If this is x, 180 minus x makes these friend. So here, A makes 180 minus A. Good with that? Then, can anybody do this guy?
180 minus A plus B.
Agreed. Because now we're looking over here only. This whole total is 180. Just like this total was 180. Here, this 180 only had to ditch the A. When we were looking at this side, 180 just like ditched the A frame. Over here, 180 has to ditch both A and B.
Okay.
You good with that? what if I asked somebody to do this total now? How much would this total be?
A plus B.
A plus B. Does that make sense? Then give the one a whirl. The picture in the book has like X's and Y's. It's about the same thing. Anybody else 106 or 109 or 110 or 103 or any of those pages, even older stuff, if you've got something you're working back to old days and you're trying to improve your homework, I would do any question from any page, anywhere in the universe of these pages. Does anybody have anything that I can do to try to make the problems a little better accessible to your life? So let's do this. If you have something that's as good as it's going to get from 106, send it down. If you have something as good as it's going to get from 109, send it down. If it's going to be a little bit better later in the afternoon, just get me later with those. At some point over the weekend, I'll score those. Before you leave, I need to give you back your 103s, but I'm not expecting to see the 103s today. It's fine. We can get the 103s next week, no biggie. But the 103s are coming back to you with the idea of draw the picture, draw the given, draw the proof, make the columns, see what you can do with those. Let's go 112 and try to get a little bit of homework. 112, momentum built up. If you didn't start this yet, just steal what we do together, and it's your lucky day to build up a little free momentum into the newest of the homeworks. So 112, here we go. Number 1, we should be able to fill in the first blank pretty well, I would think. Most people, all people. It is 38. You just copied that. We're just looking to copy that from the given. So on your homework, you would want to probably do your numbering system something like this. Here's homework problem number 1. And then I'm doing statement 1 is 38. Statement 2. What is statement 2? 52. We just copied that up from the top. What's reason 2? Also given. Because we're just copying that still up from the top. My personal taste is I would have written like a combination like double statement, single reason, but that's not right or wrong, that's just style. Statement 3. If they're going to add A and B, what's the missing number? 90. Just adding the numbers. Reason 3. What property allows you to do that? Not yet. You're a step ahead of the game. All they did was add stuff. So
Angle addition.
Warmer?
The A.
It is APE. We had equal things, we added them. Here's how we know it's not angle addition postulate. Angle addition postulate relies on that picture. We don't have that picture. So if you don't have this picture, it's not angle addition postulate. It is APE, just for us to add the numbers. That's all that they were doing there. Then the first appearance of the word complementary comes in statement 4. So as that word emerges from the first time, reason 4 must have something to do with that. That's what with complementary?
Complement.
Definition complementary, yes. That's the kind of thing we're trying to do all throughout the homework. That one's probably easier than that. But that's like the kind of thing we're trying to do. Question about 1. Let's tackle 2. Before I tackle 2 or even look over there, is this part of the picture? For 2? Yes, that's in there. It's like this plus some other things. There is probably going to be some angle addition postulate going on in number 2. So let's find those. You don't always have to go in order. You can, but you don't have to. What's the angle addition postulate going to look like? Statement stuff. If blah is in the interior, blah, then what's the then in it?
Like the bigger one equals the measure of the smaller one.
Yeah. So we want to have measure equals measure plus measure. Where in 2 do you see measure equals measure plus measure?
6 and 7.
6 and 7. Before we just commit to 6 and 7 being angle addition postulate, let's check the picture and make sure it still makes sense. But if we check the picture, DAB, if you find DAB and you find CAB, adding them up, does it make sense that it makes CAB?
Yes.
Yes. Does 7 also make sense?
Yeah.
Yes. So I'll commit 6 and 7, angle addition postulate. Question about how we squatted those? This is a launch off of the one that I did yesterday, right about here. I did a proof. I didn't have time to do all the statements, but I did like a quick outline of a proof. I was taking that off of page 111. So all of the reasons that got used on page 111, those are the reasons that are going to get used on number 2. So if you want to do like a quick flip back and forth, that's what we're going to use. So on 111, find the givens on 111. Where are those going on 113? Where are the givens going to flow?
1 and 2.
1 and 2. 1 and 2 are going to be the givens. They just separated them on that page instead of keeping them together, I guess, on the other page. Then let's do a think along. Think along is an effective way to do this too sometimes. If angles are congruent, what do you know about angles that are congruent?
Same measure.
Same measure. And that's what they're doing in 3 and 4. Angles were congruent in 1 and 2. Measures are equal in 3 and 4. What's the name of that fact? Definition of congruent angles. There is never going to be a definition of congruent, but there will be a definition of congruent segments, a definition of congruent triangles, a definition of congruent angles, a definition of congruent thises. So definition of congruent angles is a win for 3 and 4. What's new about 5?
It's adding.
It's adding. So what do we think is our likeliest outcome? Because we already spotted AAP. APE. 5 is going to be APE. Transitive is coming. Before transitive can come, how did we know over here that transitive was coming? What was the signal? How can we still see it on the board? What did I do to signal the impending transitive hood?
The middleman.
Middlemen. I started circling stuff that matched as my middlemen. As soon as I've got some middlemen matches, transitive is now lurking about. So skim 5, skim 6, skim 7, do you have some middlemen?
Yeah.
Yeah, who's one of the middlemen?
DAB.
Plus DAB plus CAD. Cover them all up with your finger. What's another middleman that still is here to look at with our eyes? CBD plus DBA. Cover them up with your finger. Who didn't you cover up with your finger?
CAB and CB.
CAB and CBA. So they get to be equal to each other in number 8, that is. What reason did we say we were just hunting? Transit. Then think from 8 to 9, if measures are equal, does that mean anything to us? Angles are congruent. What's that fact? Second time in this problem. Definition congruent angles. That's what's going on with 2. I hope it's feeling a little bit better. Make sure you erase that later. Make sure we're feeling a little bit better about this. 3 is a weird question, so we'll just keep giving away answers. How's the angle addition postulate start? If something's in the interior. That's what they're talking about in 3. Did we ever say that as we did 2? No, but did we sort of use it? Sort of. Okay, so 3, they're saying there's an unstated, meaning we didn't talk about it, but a fact that is part of the angle addition postulate. It is that D was in the interior. 4 and 5, 4 is a little bit weird like 3, 5 is a standalone question, 6 is a little bit weird. So if you get baffled by 4, 5, 6, don't just get baffled by 4, 5, 6 and make you quit. Go to 7. 7's more like 2. 8's more like 2. 9's more like 2. If you get baffled on one of these, skip it, go to the next one. Every one is not necessarily related to the one before it. Just because one makes you quit doesn't mean the next one is still bad. So skip around if you have to.